Hello, everybody, and Happy New Year to anybody watching across the world who's already ringing the new year. I hope it's a good one for you. Today, we are going to talk about graphing linear inequalities. And we're going to start out with one variable linear inequalities, then we'll go into two variable linear inequalities. So, we have our coordinate plane set up, and then you just have the inequality x is less than or equal to 6. First thing you want to do is look at the sign. Does it have an equal to component or not? That is important because if it has the equal to component, you're going to draw a solid line. If it doesn't have the equal to component, you're going to draw a dotted line to denote that x equals 6 is not part of the solution. But since it has the equal to component, we're going to draw a solid line. And you're going to treat it like you would the graph of x equals 6, which would be a straight vertical line through x equals 6. So let's find x equals 6. We'll draw a straight vertical line through x equals 6, right? So that takes care of the equal to component. That denotes that x equals 6 is part of the solution. Now for the less than component, when you graph these inequalities, we're going to make a mess here. All you're going to do is shade the entire region to the left of it, since it's less than or equal to 6, because it takes on every x value less than 6 also. So you would shade everything to the left of x equals 6. To denote that everywhere to the left of x equals 6 also is part of the solution. So that's what the graph of x is less than or equal to 6 would look like. It would be a solid line at x equals 6 and then shade everything to the left of that. And I got more. All right, what do we got next here? We have that 10x is greater than or equal to 10/3. So we have 10x is greater than or equal to 10/3. Well, you want to just solve for x for your linear inequality to get a good graph of this. So divide both sides by 10. This would all turn into the fact that x is greater than or equal to 1/3. This would be the same as the graph of x is greater than or equal to 1/3. So since this inequality has the equal to component, it's going to be a solid line drawn through x equals 1/3. So let's find 1/3, which would be about right there. Alright, so there's the line at x equals 1/3. It's solid to denote that it's part of the solution. And since you have the greater than component, you're just going to shade everything to the right of the line. That'll denote that everything to the right of it, everything greater than this line, is also part of the solution. So you're going to graph a line since it's got the equal component, you'll draw a solid line through x equals 1/3, and then you'll shade everything to the right of that since it's the greater than component. All right. Now, let's see here. We have negative 3y is less than 21. So we got negative 3y is less than 21. Well, just solve this inequality for y. If you solve it for y, this would turn into y is actually greater than negative 7. So this would turn into y is greater than negative 7. So now we're going to graph that. Now this has no equal to component. It's just simply greater than negative 7. So through the line y equals negative 7, you're going to draw a dotted line since it's only greater than and not equal to. You'll draw a dotted line to denote that y equals negative 7 is not part of your solution. So let's draw a line through y equals negative 7, a dotted line at that. All right, so there's my dotted line at y equals negative 7. Now, since it's greater than negative 7, I'm going to shade everything above it. So I'll take my marker and I will shade everything above y equals negative 7 with that dotted line. So this literally denotes everything above y equals negative 7 is the solution. So your graph of y is greater than negative 7 would look like a dotted line through y equals negative 7. Then you shade everything above that, which will give you your graph of y is greater than negative 7. Alright, so let's do one variable inequality, and then we'll start doing some two variable inequalities. All right. we have y is less than 0.75. So we are given the inequality y is less than 0.75. Well, it's just less than. There's no equal to, so it's just less than. So you're going to draw a dotted line through y equals 0.75, which would be right about here for 3/4. Alright, so there's my dotted line. And then since it's less than, well, just shade everything below the line since it's less than. Yeah, I think we get the idea that that part's going to be shaded too. I just don't want to destroy my axis if I can help it. Because it's kind of a pain to have to redraw the whole thing. So I'm shading everything below the dotted line at y equals 0.75. That would denote that y is less than 0.75. Alright, so now we're going to get into two variable inequalities. Alright, now, what if we had something like y is less than or equal to 3x plus 11? So we have that, y is less than or equal to 3x plus 11. Well, just like with the one variable linear inequalities, you ask yourself, does it have an equal to component? If it does, you're going to draw a solid line through y equals 3x plus 11. If it doesn't, it would be a dotted line. So we need to graph this. I could add a couple more to this. 10, 11, 12. There. Okay, so I'm going to go ahead and graph this here. Of course, we have the y-intercept at 0, 11. So that's a good point here, 0, 11. Let's find one additional point. What if I put in -1? If I put in x equals -1, I would get 8. Whoops, I actually graphed that at 12. My bad. Here's 11. I want to have an accurate graph. That's kind of important. Ten, 9, 8. Alright, so now you draw the solid line through y equals 3x plus 11. And there's your graph of y equals 3x plus 11. Now, y also has the less than component. So we've drawn a solid line to include y equals 3x plus 11 in our solution. Now, where are we going to shade? Well, we're actually going to end up shading everything below the line since it's less than, which is going to look more to the right of the line. But in this case, you'll shade everything below the line since it's less than 3x plus 11. So everything below the line since it has the less than component. Which is going to look a little more to the right in this case, since the way its slope goes. So in an inequality of two variables, if it's got the less than component, you shade below the line. Now if this were greater than, you would shade above it. That's how you would know what to do in those situations. Alright, I got more of these. Alright, what's the next one? So y is greater than negative 4 minus x. So we are going to graph the inequality y is greater than negative 4 minus x. Well, what we want to do then, ask ourselves, does it have an equal to component? In this case, the answer is no. Since it's just greater than, you're going to draw a dotted line through the line y equals negative 4 minus x. So let's go ahead and let's start with the y-intercept, which would be at 0, negative 4. Now, since you're going to be graphing this with a dotted line, since the line itself is not included as part of the solution, draw yourself an open circle at 0, negative 4. The reason I say that is because you don't want to include 0, negative 4 in your solution. Now let's find one additional point. Let's put in 1 for x. So negative 4 minus 1 would be negative 5. So put an open circle at 1, negative 5. And then now you're just going to draw a dotted line to connect these points and go through them. Alright, so there is y equals negative 4 minus x itself, but it's a dotted line since y is just greater than that. It's not included in the solution. So now we have to shade the region that's greater than this. So Since it's greater than, you're going to shade above the line, or in this case, it's going to be to the right of it. So we'll shade everything above it, which in this case would be to the right of it. Alright, so we have drawn a dotted line through y equals negative 4 minus x because the line y equals negative 4 minus x is not part of the solution. And then you're going to shade everything above the line because y is greater than negative 4 minus x. So that's what the shading of that would look like. And I know it looks like a hot mess when we shade stuff, but graphing linear inequalities is very important to understand. Alright. Now what if we have something like 3x plus 12y is greater than 4? So we have 3x plus 12y is greater than 4. Well, first thing you want to do is right away, since you're dealing with an inequality, don't even play with this. Well, actually, no. I take that back. First, ask yourself, does it have an equal to component? The answer is no. It has no equal to component whatsoever. So it's going to be a dotted line through 3x plus 12y equals 4. So we're going to draw a dotted line through those points. So solve for the x-intercept. That would give you, of course, 4/3 0, which would be right about here. Draw an open circle to denote that 4/3 0 is not part of the solution. Now the y-intercept would be at 0 1/3, which would be right about there. Draw an open circle there to denote that that's not part of the solution. Go ahead and graph your dotted line through those points. Alright, so there's the dotted line. Now, in order to know what region you're really shading, you need to convert this, once you've drawn your line, convert this to slope-intercept form. If we convert this to slope-intercept form, that's going to, of course, you would start out with 12y is greater than negative 3x plus 4, which would end up then turning into y is greater than negative 3/4 x plus 1/3. So that tells you that y is greater than that line. Since it's greater than, that means you need to shade above the line. So we will shade everything above this dotted line now. And there is your graph of 3x plus 12y is greater than 4. So you shade everything above the line. And there you go. And it's a dotted line since it's just greater than. I think we'll do one more and call it a day. Yeah, let's do one more and call it a day. Actually, I think we'll do two more. We'll do two more, because I'd like to have another less than. That'd be nice. All right. Actually, here, let's work on these. Less than or equal to. Okay. So we have 9x minus 2y is less than or equal to negative 18. So we have 9x minus 2y is less than or equal to negative 18. Well, do yourself a favor. Of course, ask yourself, does it have an equal to component? It actually does in this case. So that means through the line 9x minus 2y equals negative 18, it'll be a solid line. So let's find our x-intercept. Well, that would be at negative 2, 0. So there's your x-intercept. You can draw a solid line, a solid dot at that point since it is included in the solution. And then your y-intercept would be at 9, 0. Draw a solid dot at 9, 0 since that's part of the solution. Now you draw a solid line through the graph since you have the equal to component. Alright, now what you need to do to know which region you're shading, you want to convert this into slope-intercept form. So let's go ahead and get the y by itself first. Well, that would give you negative 2y is less than or equal to negative 9x minus 18. Well, if we solve for y, that's actually going to flip the sign since you have a negative. So you would get y is greater than or equal to 9 halves x plus 9. That's why you always want to convert to slope-intercept form so you know which area you're shading. Now we have that y is greater than that line, so that means you're going to shade everything above it, or in this case it's going to be to the left of it. So you will shade everything above the line here in this case. And so since you had the equal to component, you drew a solid line through 9x minus 2y equals negative 18. And then since this turned into y is greater than positive 9 halves x plus 9 for slope-intercept form, you shade everything above the line, which is going to look a little to the left of it in this case. So that is the graph of this linear inequality. Actually, I think that's good enough, honestly, because it's just more of the same type of stuff. So next lesson, we are going to talk about piecewise functions. We've never talked about that in any of the previous courses, and some of you may or may not be familiar with piecewise functions, but that's the first new exclusive of Algebra 2. We're going to talk about those. So I hope everyone has a great day. Again, Happy New Year to everybody, and I will see you all in the next lesson.